Welcome. This is section 13.1 where we will be diving deeper into areas between the two curves. But before we do that, I just quickly want to recap on what we did in 12.4. Remember, integral gives us area under the curve. So let me erase this one here. And as we've seen, these are two curves, and what integral does is it kind of finds the area between the curves by these small rectangles, by finding the areas of the small rectangles. Sometimes they're the left rectangles, sometimes they're the right rectangles, depending on where the curve touches the end point of the rectangle, which is taken as the height. So always keep this in mind. Integral gives you the area under the curve. Now that we recap, let's go ahead and take a look here. So what this section 13.1 covers is it asks us to find the areas between two curves. What are the conditions? If I have two continuous functions, f and g, where f of x is greater than g of x over the interval a to b, then the area under the curve over that interval is going to be integral of f minus integral of g of x. Now in the first problem, they're asking us to find or write down, hey, how do I find area of this curve? So first step, I'm going to go ahead and take a look. Okay, so these are two curves. I'm trying to find the area under this curve that is starting from A to B. This yellow area is what I'm trying to find. So when you're using integrals, what it does, it changes these, or just calculates the area of these rectangles like we've seen in the previous case. So what it's doing is it's just changing these into small rectangles and then adding all the areas of the rectangle, and it's giving you the final area under the curve. So that's what's happening in the back end when you're using your integrals. So how do I find? I will first find the integral. This is y is equal to 0. So this is just simply, I don't have to subtract anything. So I'm finding the area under the curve from A to B, and here is my curve f of x dx. Now keep in mind that this area is below x-axis, so this is going to be negative. So all I have to do is just stick a negative sign here, and this is going to be the area under the curve. Fair enough, from A to B. Now let's go ahead and take a look. Is that the next problem? Yeah, now let's go ahead and take a look at, let's do this one first and then let's come back to the other one. Refer to the figure to the right, and it's asking us to set up a definite integral that represents the indicated shaded area over the interval A to C. So let me zoom this in here. So I only want the area from A to C. So let me go ahead, take my pen here, and I only want this area. Let me thicken this up. So from here, from A to C. So if you look closely, my area would be just this part and just this part, because that's the area between the curves, right? So how do I find that? To do that, let me erase these markings first. I will have to find the area of, wrong pen. I will have to find the area of this portion and then add it to the area of this portion. So let me use different colors here. This portion, and let me use blue and red so you can see. So first let's find the area of the red curve. I'm going to use red color for that. Area of the red curve. And this is, the line is my function f of x. So as you can see, this is f of x minus the curve below. I think I did too much here. Let me reduce the pen color here and just do it this way. Yeah, that's much better. And so I'm trying to find the area of the red and the blue. So the red one, the area of the red curve is going to be this line here, which is f of x, minus area under this curve, which is h of x. F of x minus h of x dx. integral. But from what point to what point? Only from A to B. A to B. Now for the blue curve, as you can see, the curve above here is h of x. So it is integral h of x, and the one below is f of x minus f of x dx from integral b to c, always from left to right, b to c. And as you can see, if the curve is above, you write that curve first. If the curve is below, you write that curve second. And then all you have to do is simply add these two areas, and that's what gives you the area of what they're asking you for. Okay? Now, let's go ahead. Again, you can go back and rewind this video and take a look as how I got the red area, how I got the blue area. Now, let's go ahead and take a look here. It says, find the area bounded by the graphs of the indicated equations over the given intervals. Okay, so you already gave me the interval from -3 to +3. And here I have the curve 1 and curve 2. But it's always nice to visualize. You will be having your graphing calculators. So I would like you all to go ahead and graph this. This is -x² plus 20. And y is equal to 0 is my y-axis. And I'm trying to find the area between -3 and +3. So the area that I'm trying to find is this part. Okay? That's the area I'm trying to find. So when you have this visual representation, you will know which graph goes on the top and which graph goes on the bottom. Okay, so this is my graph -x² plus 20, and this is y is equal to 0. Now that I know, all I have to do is simply set that up. So that's going to be, I know from -3 to +3, what's my area on the top, curve on the top? My curve above is -x² plus 20 minus my curve below is y is equal to 0. So subtract the 0. Remember, it's integral a to b f of x minus g of x dx. So this whole thing dx. And now let's go ahead and simplify this one. But the key point here is to see which curve or which function goes on the top, which function goes on the bottom. If not, then your whole answer is going to be negated. Once we've done that, let's go ahead. When I simplify this one, what do I end up with? I end up with -3 to +3 -x² plus 20 dx. And when I find the integral, let me go ahead and find the integral. This is -3 to +3. Integral of -x² is -x³ over 3. Integral of 20 is +20x. And all I have to do is plug in my -3 and +3. And as you know, you first plug in your +3. So -3³ over 3 plus 20 times 3 minus, I am going to put these in parentheses as well, minus -3³ over 3 plus 20 times, do I have space, times -3. And when I go ahead and do that, these two cancel off, and I end up with 60 plus 60, which is 120. And that's exactly what you have, 120 square units. Okay, but the key point is you'll plug in your upper limit minus your lower limit, or the interval. Okay? All right, now let's go ahead and take a look at the next one. Oh, wait a minute. In this one, they did not tell me what areas should I find. Like in this one, here they gave me the interval. So it's easy for me to go ahead and do it. Just put the interval in. But if I look closely here, it says find the area of the region enclosed by the curves. And that's it. I don't have the region. I don't have the interval. So to do this, again, you'll be using your graphing calculators. But let me go ahead and show you what happens here? I'm going to go ahead and graph this one. This is, let's see. Again, you'll be using your graphing calculators. X squared minus 3 is the graph of x squared 3 units down, and y is equal to 6 is here. Okay, now all I have to do is have to find the area between the curve, which is this area. This is too big. Which is this area. But to find the area, I need to know these points. And what are these points? Are the points of intersection. How do I do that? Let me show you. Again, you'll be using your calculators, but what if you don't have your calculator? This is the simplest way. My step one is to go ahead and find the point of intersection. Points of intersection. To do that, I will simply equate both my curves. That is, x squared minus 3 is equal to 6. So x squared is equal to 9. So x is equal to plus or minus 3. So these points that you see are -3 and +3. So now all you're trying to do is find the area between -3 and +3. Once you have that, you see that the upper curve is y is equal to 6. And the curve below is x squared minus 3. Once you have that, easy peasy. It is integral a to b f of x minus g of x dx. Which is, I know my a is -3 to +3. The curve on the top is 6. Y is equal to 6. And the curve in the bottom is negative of x squared minus 3. And when I simplify this, don't forget your dx. When you simplify this further, you will have integral -3 to +3. I have negative x squared plus 9 dx. So you got to be very careful when you're doing your integrals. And once this is done, I'm going to go ahead and find my integrals. I'm going to use a different color so you can see. This is, the color is not that visible. So I'm going to go ahead and use this one. So this is -3 to +3. Integral of negative x squared is negative x cubed over 3. Integral of 9 is 9x. And now, once I have this, I'm going to plug in my interval +3 and subtract from -3. So let's go ahead and do that. So this is, I gotta be very careful here so I don't make any mistakes. So this is going to be negative of 3 cubed over 3 plus 9 times 3 minus, I always like to put parentheses so I don't make any mistake, negative 3 cubed over 3 plus 9 times -3. Remember, it is f of b minus f of a. So this is your a, this is your b, f of b minus f of a. And once you do this, -3, what do you get? This is this is 27 over 2 cubed 9. This is -9 plus 27 minus, what do I end up with? 9 minus 27. Yeah, and this is 54 minus 18, which is 36 square units. Again, you don't have to do this manually. You'll have your calculators to plug in. So there you have 36. Okay, but the key here is to see which curve goes above, which curve goes below. So it's always nice to have your calculators next to you so you can graph and visually see what's going on. Now let's go ahead and take a look at the next one. I like when they give me the interval from 1 to 2. But again, for me to see which curve goes on the top, which curve goes on the bottom, I have to graph it. So when I graph this, this is my graph of y to the power ex. Y e to the power x. And for the graph of negative 1 over x, it is going to be something like this. And let me use different colors. Why am I using the same color? This is the graph of 1 over x, negative 1 over x. And what they're asking me is, they're asking me to give me the area from 1 to 2, from 1 to 2. So this is the area that I'm trying to look for. Here I don't see there are any points of intersections here. All I know is one is on the top and one is in the bottom here, which is negative 1 over x. So let's just go ahead and do it. So this is integral. So you see when we graph it, I'm finding from 1 to 2, area above minus area below. Area above is e power x minus area below is minus of negative 1 over x, the whole thing dx. So every problem is going to be different. Some of them will have points of intersection, some of them will not. So it's always nice to graph and see what your graph is and how or what they're asking you to give. Okay, now once we know that, let's go ahead and simplify this one. This is going to be integral 1 to 2 e power x, negative of negative makes it a positive, 1 over x dx. So once I find the integral, I will change the color to dark red. This is 1 to 2. Integral of e power x is e power x. Integral of 1 over x is plus ln absolute value of x. And now I have to plug in my interval, upper bound, lower bound. So let's go ahead and plug in my upper bound first, which is e power 2 plus absolute value of ln 2 minus my lower bound is e, I like to put parentheses here, please make that a habit so you don't make any mistakes, e to the power 1 plus ln 1. ln 1 is a 0. When you plug this into your calculators, I think you get 5, let me see, what do I have here? 5.3639. And that is your final answer. That's the area under the curve. So you see the beauty here, just by using the functions and finding the integrals, what you're doing here is you are changing this area into these small rectangles, adding all those rectangles and giving me the area. Now let's go ahead and take a look at this problem. Find the area bounded by the graph of the indicated equations and compute the answer to 3 decimal places. As you can see, this is a whole cube here, and I have y is equal to x plus 10. So again, I would like to go ahead and graph this. And first I'm going to graph my y is equal to x plus 10 because that is easy. Negative 10, positive 10. I'm going to go ahead and graph that. And this is x cube. So my graph would be x cube something. Let me move this. Like that. Always graph it and see what's going on. Always graph your function and see what's going on. And as I can see, I have 3 intersection points here, and I'm trying to find the area under the curve. That means I am trying to find this area, and I am trying to find this area. Let me just increase I'm trying to find this area. So as you can see, one area is above, one area is below. Area above is always going to be positive, area below is always going to be negative. Now the only thing is, how do I get to these intersection points? Very simple. What we do, like always, is we equate the equations to find the point of intersection. X cubed minus 3x squared minus 27x plus 10 is equal to x plus 10. That's how you find your point of intersection. So 10 and 10 cancel each other. I bring the x to the other side. So I have x cubed minus 3x squared minus 27x minus x is equal to 0. X cubed minus 3x squared minus 28x is equal to 0. Factor the x out. I have x squared minus 3x minus 28 equal to 0. Remember, your goal is to factor this and find the points of intersection. And when I factor this, I have x minus 7, x plus 4 equal to 0. So I know my points are x is 0, x is 7, and x is negative 4. That means this point is negative 4, always going from smallest to the biggest. This point, that means this has to be a 0. It has to be somewhere here. Let's see what I can do. What I'm going to do is I am going to pick, oops. Why am I not able to pick this? Okay. Okay. I'm going to move this just here so you can see that's on the 0. Okay. So this is 0. This big point is 0, and this is 7. So now I have to find area from negative 4 to 0, negative 4 to 0, and from 0 to 7, the one below. Okay? So there's two parts to this equation. Let's go ahead and do it step by step. I am going to use two different, this is from negative 4 to 0, and this is 0 to 7. Again, how do I find from A to B area f of x minus g of x dx, right? Don't forget that. So I know this is integral negative 4 to 0, and this is integral 0 to 7. So let's start from negative 4 to 0. What curve is on the top? As you can see, the x cube is on the top, and y is equal to x plus 10 is on the bottom, right? So what you do here is, it's going to be x cube minus 3x squared minus 27x plus 10 minus x minus 10. Let me make sure they are correct. Yeah, minus x minus 10. I'm going to come back to 0 to 7 in a minute. And now I'm going to simplify this one. Positive 10, negative 10 cancel. And I will have integral negative 4 to 0, x cubed minus 3x squared minus 28x dx. Okay, and now let's simplify this one. Let's find the integral. This is going to be x to the power 4 over 4, again negative 4 to 0, minus 3x cubed over 3 minus 28x squared over 2. Again, now once I'm done with my integral, your next part is to go ahead, plug in your lower limit and your upper limit, right? F of b minus f of a. And if I look closely here, my f of b is 0. So when I plug 0, everything becomes a 0. So this is 0 to the power of 0 over 4, 0, 0, 0, 0. So 0 minus, and now I'm going to plug in my negative 4. Negative 4 to the power 4 over 4 minus 3. You see how I always have parentheses just to make sure I don't make those mistakes, and I would highly recommend plugging it the same way in your calculators. I don't think I need this line here. Okay. And now what do I end up with? This is 0. Let me plug the whole thing into my calculator. I end up with negative 96. So negative off negative makes it a positive 96. Now that part is done. Now let's move on to the 0 to 7. When I go back here from 0 to 7, look what graph is on the top. The y is equal to x plus 10 is on the top and x cube is in the bottom. So now you will have x minus 10 minus the entire x cube minus 3x squared minus 27x plus 10. I mean, if you know the answer is going to be negative, you can simply go ahead and just, instead of getting a positive answer, just make it a negative. You can do that too. What I mean is you can just use the same function on this side and change it to a negative. That's absolutely fine as well. So now what do I have? Let me go ahead and simplify this one. This is integral 0 to 7 x minus 10 negative x cube positive 3x squared positive 28x and negative, this is x plus 10, yeah, x plus 10, yeah, negative 10 and dx. And now as you can see, positive 10 negative 10 cancel each other. Did I already change this to 27? This is 27, not 28. This is 27. Okay, now what I have is integral 0 to 7 negative x cube positive 3x squared plus 28x dx. And if you look closely, it's exactly the opposite of what we got there. Again, what do you do once you have this? I'm going to find the integral. You don't have to because we found that before. This is negative x power 4 over 4 plus integral of this is 3x cube over 3 plus 28x squared over 2. And once I have this, I'm going to go ahead and plug in my 0 and 7. As we've seen before, I don't have to plug in a 0 because this whole thing becomes a 0. So I'm only going to plug in my 7 here. So when I plug in my 7, this is going to be negative 7 to the power 4 over 4 plus 3 times 7 cube over 3. Now you might say, Miss, why don't you cancel the 3? You can. I am just trying to keep it as simple as possible. And when I plug all this into my Desmos, what do I get? Or your calculator, I got 428.75. And now I have my two areas. And now what do? You simply add these two areas. So when you add them, 96 plus 428.75, you end up with 524.75. And that, my friends, is area under your curve. So as you can see, I broke this down to negative 4 to 0, 0 to 7. You didn't have to do this entire step here. You can simply use the same integral here, but you have to make sure you you negate your answer. So you probably will get negative 428.75. You'll make it positive because the area is under x-axis or under the curve. And once that's done, you will simply go ahead and add both of them, and that's exactly what you have. But for me, I like to see what goes on the top, what curve goes on the bottom, the above, what curve goes on the top, what curve goes on the bottom, so I can visually see and subtract. Hope this helps.